Welcome to my channel Learning Electronic Circuits. Today I am going to talk about the light emitting diodes or LEDs. We'll go through the definition of an LED, the different parts, the working principles, types of LEDs, advantages, disadvantages and its applications. An LED or light emitting diode is a semiconductor diode that emits light when an electric current flows through it. When the current passes through the LED, the electrons recombine with holes at the PN junction, emitting light during the process. The LED allows the current to pass only in one direction and not in the reverse direction. Parts of an LED. The LED consists of two electrodes, the anvil which forms the cathode and the post which forms the anode. The anode has the longer terminal and cathode the shorter one. The anvil contains the semiconductor die in a cavity that has a reflective surface. A thin wire or wire bond extends from the anode post to the semiconductor die. The whole structure is encapsulated inside an epoxy resin lens or case. This epoxy resin enclosure helps to protect the LED from the vibration and shock. There is a flat surface at the rim of the encapsulation near the cathode, which indicates the cathode terminal. Working of an LED. The electrons and holes recombine at the PN junction of the semiconductor and produce light. This process is called as electroluminescence. The electrons from the N region cross to the P region and recombine with the holes present in the P region. Free electrons are in the conduction band energy level and holes are in the valence band of energy level. The conduction band where the electrons reside is of higher energy level than the valence band that has holes. Therefore, some part of energy is released when the electrons recombine with holes. This energy released is in the form of light in LEDs. The materials used in diodes consists of germanium and silicon, and the energy is released in the form of heat, whereas the LEDs are made up of gallium arsenide phosphide and gallium phosphide semiconductors, where the emission consists of light. Special coatings that reflect light and physical features like dye shape are utilized to effectively focus the light that is produced. The epoxy resin body reflects the photons of light emitted by the junction away from the substrate base and focused upwards and towards the dome of the LED. All 5 mm LEDs need a forward operating voltage between 1.2 to 3.6 volts to light up and consume a current of 10 milliamps to 30 milliamps. The exact forward voltage is dependent on the type of semiconductor and the doping materials that are used. Color of LED. LEDs give out radiation of wavelengths from infrared, colors of the visible spectrum, to ultraviolet depending on the semiconductor used. It also provides low, intermediate to high output of light for various purposes. The emitted light from the LED is very narrow. It is not spectrally coherent or monochromatic. The actual color or wavelength of light produced is dependent on the bandgap energy of the semiconductor used. In silicon or germanium, called as the indirect bandgap materials, the electrons and holes recombine by dissipating energy in the form of heat, whereas in direct bandgap materials such as gallium arsenide phosphide and gallium phosphide semiconductors, the transition happens with emission of photons. The PN junction of the semiconductor will emit light, thus forming a light emitting diode. The wavelength and its color depends on the bandgap energy of the semiconductor materials that forms the PN junction. The semiconductor materials used in LEDs have a bandgap energy which produce radiation that corresponds to infrared, visible or ultraviolet light. LEDs are available in a wide range of colors such as red, amber, yellow, green, blue, white, etc. The color of the epoxy resin encapsulation does not determine the color of the LED, but it enhances the color produced by the semiconductor material and to identify the color when it is not illuminated. Types of LED. The LEDs are of different types used for various applications. The different types of LEDs are as follows. 1. Miniature LEDs. These are used for indicator lamps. It is shaped as round and domed on top, flat top and rectangular, square with a flat top, triangular, etc. LEDs may be clear or tinted for better contrast and viewing angle. Infrared LEDs have a black tint to block visible light. 2. High power LEDs. These LEDs can emit powerful streams of over 1000 lumens of light. They consume high current and dissipate a lot of heat. Therefore, heat sinks are provided. These LEDs are used for lighting. 3 AC driven LEDs. It can operate in AC power, where part of the LED emits light and the other part remains dark. This is reversed in the next cycle. 4. Flashing LEDs. These LEDs are used as attention seeking light indicators. It does not require any external electronics. 5. OLEDs or organic light emitting diodes. This is an LED with an electroluminescent layer, which is made from a film of organic compound that emits light when current passes through it. 6. Bicolor LEDs. Here two LEDs are connected in opposite directions in a single case. The current flows in one direction and will light up one LED, and the reverse flow of current will light up the other. 7. RGB tricolor LEDs. It contains 3 LEDs in a single case. It consists of red, green and blue colors with their leads and a common ground. With proper switching of these LEDs, a mixture of different colors are produced. 8. Decorative multicolored LEDs. Here several multicolored LEDs are connected together by their supply leads. Colors are switched by powering each LED in a different sequence. 9. Alphanumeric LEDs. These are available as a 7-segment or dot matrix variety. It contains both numbers and some letters. 10. Digital RGB LEDs. These LEDs contain their own control devices, connections for data and other signals. It is used in Christmas lights and LED matrices. 11. SMD LEDs. These are LEDs mounted on a board to allow dissipation of heat. 12. LED filament. Here multiple LEDs are connected in series on a common longitudinal substrate that forms a thin rod. Advantages of LEDs. LEDs have many advantages compared to conventional lighting, and they are as follows. 1. Efficiency. It has low power consumption. It emits more lumens per watt than conventional lighting. 2. Lifetime. It has a longer lifetime of more than 35,000 hours. 3. Color. LEDs can emit light of any color without using any external filters. 4. Size. The size of the LED is small, so it can be easily mounted on a suitable surface. 5. Switching speed. LEDs can undergo frequent on and off switching. 6. Shock resistance. LEDs are not damaged by external shock as they are made of semiconductor. 7. Focus. LEDs are available with focus light and do not need external focusing. Disadvantages of LEDs. The important disadvantages of LEDs are as follows. 1. Temperature dependence. Overdriving an LED in high ambient temperature results in the failure of the device. 2. Voltage sensitivity. LEDs must be supplied with a voltage above its threshold voltage and below its maximum voltage and current limits. 3. Color rendition. The spectral spike at 460 nm and a dip at 500 nm can make the color of objects appear differently under cool white LED illumination than under sunlight or incandescent light. 4. Area light source. Single LEDs are not a point light source giving a spherical light distribution, but instead they show a diffuse light pattern. 5. Light pollution. White LEDs emit shorter wavelength of light, which leads to more sky glow when used outdoors. 6. Efficiency drop. The efficiency of the LED is decreased when the supply current is increased. Heating also increases high current flow through the LED. 7. Impact on wildlife. LEDs attract insects and thus interfere with the normal food web. 8. Use in winter conditions. LEDs give out less heat, so when used outdoors or as traffic lights, it will be covered with snow in winter. 9. Thermal runaway. Parallel connected LEDs will not share current equally due to differences in its forward voltage rating, which can lead to LED failure. Applications of LEDs. The important applications of LEDs are as follows. 1. For visual display and to convey a message. LEDs are used in traffic signals, display boards, lighted wallpapers, display meters, medical devices, electronic equipments, etc. 2. For lighting and illumination. High power LEDs are used in general lighting of rooms and buildings, automotive lighting, street lighting, camera flashes, infrared illumination in night vision cameras, horticultural lights, etc. 3. Data communications and signaling. LEDs are used to send data over fiber optic cables. Infrared LEDs are used in remote controls. The high switching rates of LEDs are suitable for advanced communication systems. 4. Machine vision systems. LEDs are used in barcode scanners, optical mouse, various sensing devices, etc. 5. Biological detection. UV light emitting LEDs help in detection of biological agents or vectors. 6. Other applications. LEDs are used extensively in fiber optic communication, optoisolators, sensors in pulse oximeters, UV LEDs are used in sterilization, etc.